all kind of places. Bottom-up estimating, we've talked about that, 3-point estimates. And let's say we're driving into the university. And let's say one of you lives down in Castle Rock. Castle Rock, got to drive to the university, long drive. So give me an optimistic estimate for getting from Castle Rock to the university. Anyone? Hour and 15 minutes, okay? So that's 60, 75 minutes. All right, so that's our optimistic estimate. Give me a pessimistic estimate. You hit all the red lights and it's snowing. Let's assume that maybe traffic's heavy, no snow, but traffic's heavy and red lights and stuff like that. Give me an estimate.
2 hours. 2.5 hours.
All right, let's go 2.5 hours. And give me a most likely. What's your most likely getting here from Castle Rock? Say again? 70 minutes? That's you're talking pedal to the metal, right? Yeah, pedal to the metal, rock and roll, and I've got I can't drive 55 on the radio, right? Okay, very good, very good. So give me a most likely estimate. We said 75 was optimistic. What's most likely? 90 minutes? Okay, 90 minutes. Okay, given those, and this is our project team, and this was one of our steps, very easy process. I'm just going to have you go through the motions. T sub B is our estimated time. So figure that out. All right. Hanuk, what do you get?
Oh, I think that's...
All right, punch the number, see what you get. Do, 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 do. I need a Jeopardy button in here. What do you get? All right. All right. So 97.5 is our estimated time. So would we have come up with 97? Well, I'm not worried about 30 seconds, but would we have been able to come up with that just as a 1-point estimate? Probably not. So therein lies some of the value, and also it helps if you're actually estimating on the project. It's a technique to help eliminate some of the potential padding, because if you just sit there and think about it, you can think yourself over one direction or think yourself in another direction.
So you're kind of building in the padding.
Well, you know, somebody asked me last semester, how come it's not T sub 0 plus 6 times the most likely plus T sub P over 8? You know, and the problem is, the problem with that is that, let's see if this thing will still work. There it goes. All right. The problem is, instead of ending up with a curve that looks like this, you end up with a curve that looks like this. Okay? And you end up putting too much emphasis on your most likely estimate, which makes that no good. So, statistically speaking, this presents a curve that's more, I would say, Gaussian in its distribution, and which means when we get ready to compute the standard deviation, the standard deviation is pessimistic minus optimistic over 6. And then get ready to use the standard deviation, it makes more sense, you know, when you start looking at standard deviations. All right, if you have something that's closer to a Gaussian distribution.